Okay, so welcome everybody to the Introduction to Programming in the Biological Sciences Bootcamp 2020 at Home Edition. um, Traditionally, we do this in a room on campus. The TAs and I are with you, interacting with you. Our fingers often touch your keyboards as well. This will be a new experiment to see how we can do it remotely. Thank you all for participating and for joining us. And hopefully it will go smoothly. I'm sure that there will be some bumps along the road, so just bear with us as we go through this. Before I begin, I just want to introduce to you our two TAs. Our two TAs are Sophie Walton and Ankita Roy-Chowdhury. Just because of the way the video works, you won't see their faces right now. I can see their faces. Or actually, I'd take that back. Because the recording works, those of you who are watching the recording won't see their faces, but the rest of you can see their faces right now live. So Sophie, if you could just please say hi and tell briefly your background and why you agreed to do this crazy TA-ship with me.
Yeah, I'm Sophie. I've just graduated with a bachelor's in bioengineering and information and data science. And I like biology a lot, and I like programming a lot. And this is my fourth class working with Justin, and it's always a lot of fun. And it was my second Zoom experience, and I was like, let's just go back for more. And so that's why I'm here. Yeah, but
excellent. Thank you, Sophie. Ankita.
Hi, I'm Ankita. I'm a rising senior undergrad at Caltech, and I'm also studying bioengineering. And I think that the stuff Justin teaches in these boot camps, as well as his classes like 103A, have really changed the way that I look at data programming, especially in biology. So that's why I'm here.
Great, and Ankita's also on the East Coast, so she's working through her dinner time. And I know some of you are in different time zones as well. Thank you for being flexible so that your schedule can match the Pacific Daylight Time. Okay, a couple more logistical things. So you have all been invited to a Slack channel. We've thought about different ways of how we were going to interact with you, and we found that having questions posed on the Slack channel is really going to be the most efficient. The reason for that is that if you have chats in Zoom, they're not well organized, they're harder to archive, whereas the Slack channel, it's much easier to organize. It's also like really done in real time, and so that's how we decided to go about doing a lot of the interactions in the boot camp. So you'll notice in the Slack channel that the channel is organized by topic in terms of exercises and lessons. So please make sure you ask your question, if you have a question, in the appropriate with the appropriate section of that. While I'm going through lessons, the TAs will be monitoring the Slack channel. If you have a question, you can put it in there, and if they think that it's something that is of general interest, they'll interrupt me and we'll go over that question. It's up to you if you want to ask it verbally as well. Just remember that if you do, then your voice will be recorded and on that unlisted YouTube channel. So that's up to you, however you want to do that. Please don't be shy with the questions. I know this is a sort of an awkward format. Normally when I'm in front of a classroom and you're in front of me, I can look at your faces and be like, oh yeah, clearly you have a question about this. What is your question? You know, but we can't do that in this format. So please do please don't hesitate to ask questions. And remember that we have people from all different levels here, from absolute beginners to some more experienced programmers. I mean, I can tell you, in one year I did this boot camp, one of the people who actually TA'd for me in a course that uses a lot of the material in the boot camp decided that she wanted to take the boot camp and she learned something. She learned a lot, actually. And so it comes from, there's a wide range of people. So any question you have, you should not feel hesitant or embarrassed or anything like that to ask it, because I guarantee you're not the only one with that question. Okay, so I want to just tell you a little bit about the philosophy of the boot camp, because that's really important. We have something like, well, it looks like Slack is telling me there are 64 people on the right now. I know there are a couple people who are participating, but are in Europe, for example, and are can only join at certain times because of the time differences. So we have roughly 70 people, I think, total involved in this thing. And again, like I said, they're from all different levels of experience. That means that our goal for you is for you to get out of the boot camp the most that you personally can get. You are, you may be more advanced than some students and far less advanced than others, and running the whole gamut. It's really about you, and we try to structure it in such a way that everybody can learn from it and can improve their programming skills and can walk away with some techniques that they can use directly in their own work. And that's ultimately our goal, is to empower you to be able to use your computer as a research instrument, right? To be able to use these incredibly powerful tools to further our understanding of biology. Ultimately, that's what we're after here, okay? So that means that there should really, I guess what I would try to say is that there's no pressure, right? You should get out of it what you can. The other thing that's a little unfortunate with this setup is that it's going to be really hard for you to work together on things because you're all kind of sitting in separate, like sometimes states or countries. If you, when it comes time to do the exercises, at the end of each day, we're going to have some exercises to do. When it comes time to do the exercises, if you want to collaborate with somebody else in the class, please, by all means, do that. You can even post on the Slack channel and say, hey, this is my level. Would anybody like to join me in working on something? Now, it's a little bit challenging to do that. You probably have to set up your own Google Hangout or Zoom session or something like that, which you can do. But please feel free to do that. During the exercises, we'll keep this Zoom session open, and we'll have discussions based on questions that people are putting in through the Slack channel. So you can always sort of, turn off the sound on your computer while you're working on something, if it's going well for you and you don't feel like you need to hear the discussion of other people's questions. One final thing to mention is that in my video, I may look like I'm looking in lots of weird places, just so you understand what I'm doing when my head is moving. I have 3 monitors set up here. I have my main one that when I'm typing, I'll probably be looking at, and this is where so this is straight away here. I have another full-size monitor that has you all in a gallery view. It is actually on a different Zoom account so that it doesn't mess up the recordings. I taught last term in Zoom, so right now I'm looking at you. It doesn't look like I'm looking at you, but I'm looking at you. Yeah, hey, Tom. So last time when last term I taught using Zoom, and I'm just not going to sugarcoat it. It was god awful, and I hated it because I couldn't see anybody, and I was pre-recording lectures, and it was like talking to the void. And I'd rather not talk to the void. So if you're comfortable, you don't have to. Don't feel obliged. But I'd love it if you guys did turn on your videos. I do look at you. I actually occasionally, like right now, I literally just switched the gallery view because you can't all fit in there. And it does help me to kind of see your faces and look at how you're responding to the material. So I do appreciate it when you do that. Okay. See if there's anything else I need to cover for logistics or anything like that. I guess I just want to reemphasize, this is for you. It's all about you. The TAs and I I are here to help facilitate your learning. So just remember that. That's the whole philosophy. It's a fair amount of time. It's for you. Normally we do it over the course of a whole week, like 1 week, crammed like 8 a.m. to 6 p.m. There was a group, a friend of mine who is faculty at another university, and she and her research group actually worked through, at the beginning of the lockdown, they worked through last year's boot camp together over Zoom. And they gave me a lot of feedback about it. And they said, there is no way you can do this. Zoom it's exhausting. And it's true. I feel totally shattered after doing Zoom for a day. Whereas if I'm on my feet actually interacting with people, somehow I'm way less tired. So that's why we're doing it over 2 weeks in the afternoons. Oh God, I forgot the most important thing. The number one thing that we're after is for trying to have you develop your skills. It's for you. Number two is for you to have fun, right? So please relax, enjoy yourself. Inevitably, when you're learning how to code, there are going to be frustrations, like serious frustrations. Like, I'm telling it to do this iteration. Why is it not doing it? I have shown my computer the middle finger more times than you could ever count. I'm sure you've shouted at your computer, threatened to throw it out the window. That's going to happen. I just encourage you, just try to have fun with it. And as when you get those little breakthroughs, you get your computer to do something you want it to do, let yourself enjoy that. It is actually very rewarding. Okay. So now I'm going to try this trick that I did where I don't show your faces while I start doing screen sharing without showing your faces. So here we go. Okay. All right. So I could get my notes here. Oh, that's strange. Okay, pardon me for a moment here. Okay. Interestingly enough, I'm just getting my thing set up too, so I can still see you and still look at my notes. These 3 screens I'm operating. Okay. All right. Yeah, real quick. Any questions about logistics? Okay. All right. So we're going to be learning about computer programming, and in the language in the Caltech catalog, I say that Python is the language of instruction. And I really do mean that. It's the language of instruction. I don't consider it to be a course about Python. I consider this to be a course about programming in which Python is the language of instruction. The reason I choose Python is because it has a relatively shallow learning curve, and it's very, very versatile, and it's not only is it versatile, but it's also very good at doing each of the many tasks that it can do. We'll talk a lot more about that on the very last day when I talk about other languages and packages. But nonetheless, as we begin our adventure into learning how to do programming, we're going to be using Python as our language. Now, as we go through the boot camp, this is the central nervous system. This is the website for the boot camp. And all of the materials are here. They're actually not all here. I still have to add a few more lessons in the last few days. Those will be there several days in advance. Don't worry about that. Importantly, if you look at the schedule down here, here's our daily schedule. So right now we're doing the welcome and the introduction to JupyterLab, and we're going to do that for 40 minutes. And then after each lesson, you're going to have a break, either a 5 or 10-minute break. The breaks are very important. This is feedback I get every year. The breaks are very important. So, so really the bootcamp consists of a set of lessons followed by an exercise. Now, as we do the lessons, I encourage you to type along with me. Having your fingers on the keys while I'm doing stuff will help cement that in your, basically in your mind as well. Just reading a book about how to program is not going to teach you how to program. You actually have to write programs. You have to have your fingers on the keys. So So what I'd like you to do is fire up JupyterLab, and you guys know how to do that. Go ahead and get that going. All right. And so this is what it looks like when you first fire up JupyterLab. Now, JupyterLab is nice because it's a nice environment where you can interact with the Python interpreter. So what do I mean by the Python interpreter? So Python is an interpreted language, meaning that as you give it a set of instructions, each line of code that you write is interpreted into a set of instructions that your machine can understand by the Python interpreter. So this is different than, say, a compiled language. So in a compiled language, you write all of your code, and then you have the compiler translate it into machine code, and then you only keep using that machine code each time, right? Whereas the interpreted language, it's as you run code from interpreted language, each line is translated into machine code and then run. Again, on the last day, we'll talk a little bit more about the differences and the relative advantages of those two. Now, the nice thing about the JupyterLab is it gives you a nice environment to interact with the Python interpreter, and we're going to do it in primarily. The other nice thing it gives you is it also gives you access to a terminal. So a terminal down here, which you guys have already done as you're setting up your computer. When we start interacting with Python, we're going to interact with the console. If we click on this, we get a Python console, and it says IPython. You can see it right here, IPython 7.13, an enhanced interactive Python. So plain old vanilla Python by itself, I very, very rarely use it, and I don't think hardly anybody does. IPython is so much more of a rich experience to use. Now, if you look down here, this is where you can enter commands into Python. Now, in your first experience with the programming language, traditionally there's one program that you write. And this program is called Hello World. You guys heard of the Hello World program? Yeah. I'm looking at some of you. I see some nods. That's good. So this actually dates back to, at least the lore is that it's Brian Kernighan, who's the guy who invented Unix. And he's author of the book on C programming. This is work in the 70s. And this is the first program in that book, and apparently that's one of the first programs that was run on Linux, was Hello World written in C. Well, we're going to do our Hello World for Python. And so I just want to ask really quickly, the text, is that big enough for you to see as you look on your shared screen? I see some nods. Okay, good. If it's not, please let us know. So I'm going to do print, and then in quotes, hello world. Now on the console, if I want the Python interpreter, so the Python interpreter hasn't done anything yet. I've just entered something, but I haven't told it to run it yet. So the way to tell the Python interpreter through IPython to run it in this console is to press the return key while you're holding down Shift. So hit Shift Enter, and now you look up here, and it gives you this prompt here, which says, "This is the first input you gave me. This is the command you entered, which is print hello world." And then what did it do on the screen? It printed hello world. You guys just wrote your first Python program for your total newbies. For you guys who aren't newbies, it's always satisfying to write a hello world. Okay, so we also learned something about some Python syntax. We learned a little bit about how functions work. So print is a function, and then the argument of the function is encapsulated in these parentheses here. In this case, the argument of the function is a set of characters called a string. So a set of characters is called a string. In this case, the set of characters are capital H, E, L, L, O, comma, and so on. And we encapsulate the string in single quotes. We can also encapsulate in double quotes. It doesn't matter. Now, so let's put this function to use. So what I'm going to do is I'm going to print the first few lines of the Zen of Python. Okay. Now, if I hit enter, notice that it didn't execute. It just gives me a new line. It won't execute until I hit shift enter. So, okay, I'll print some of these. Let's see. Beautiful is better than ugly. Ooh, learning important lessons here. Okay. Explicit is better than implicit. All right, so if any of you guys want to have a fun game, during the course of the boot camp, if any of you wants to keep a tally on how many times I say explicit is better than implicit, that'll be fun. I'll look forward to seeing what that count is at the end. Simple is better than complex. And let's see, complex is better than complicated. So now I have, let's hit shift enter and see what this does. Okay, so there it is. It tells me that this is what I entered. And then it goes ahead and it's actually printing one after another those things that I asked it to print. So we've learned some more things about Python syntax here. The first thing is that this line starts with a pound sign. And that indicates that it is a comment. That means that it is not something that the Python interpreter is actually going to interpret and convert into machine code and then run. It's just saying, interpreter, you ignore this. So the comments mean literally nothing to the interpreter, but to the human and the programmer, they mean a lot. They tell you usually why you're doing what you're doing. Okay. Now another thing we saw is that we can have different commands on different lines, and it'll execute them one after another. Now, you can imagine that hand typing stuff into a console window is going to not be the best way to construct your computer programs, because you'd have to type them again and again and again, or copy and paste, or something silly like that. So when you're writing code that you're going to use over and over again, you want to store it in a file and then be able to run the context of that file, or as we're going to talk about later this week, to import the functions contained in that file to then have all that functionality be available to you. So what we're going to do now is we're going to take this nice little program we wrote, and we can copy and I'm just going to copy this to the clipboard. You should do that too. So we'll copy it. What I'm going to do here is in JupyterLab, this is kind of nice. If I hit this plus button here, it's going to give me a new launcher. So I'm going to get myself a new launcher, and then I'm going to give myself a text file. So if I click on text file, I get myself a fresh text file called untitled.txt. I'd rather call it something more descriptive. So I'm going to rename this zen.py. Zen.py. Why do I choose it that? Well, the .py suffix is what's really important, because that's saying this is a Python file. So you typically, if you have a Python, a file that stores Python code, the suffix on such files is .py or .py. I'm going to call it Zen because it's going to contain the first 4 lines of the Zen of Python. And if I paste here, this is now the contents of this file. And I can save it. I can either do a file, save Python file, or Command S. I'm on a Mac, or I think it might be Control S on Windows. And so now I've saved this file. Okay. So I have a file called zen.py, and it's saved. And the nice thing about the JupyterLab is that over here, it's showing me that I have a file with that name. Okay. Now I'm going to go back to the console, and if I want to run that file, or actually, you know what? If I want to run the file in this IPython console here, I do this. I do %run and then the name of the file. Now this % sign here, this is a so-called IPython magic function. We'll see more magic functions when we work with Jupyter notebooks in a bit. It just says, basically it's telling IPython, okay, go to this .py file and run its contents as if it's Python code that you typed into the console. So if I do that and I hit Shift Enter, it tells me this is what I called at the prompt, and then it did the instructions that were contained in that .py file. Okay. All right, so I'm going to try to run the code one more time, but I'm going to do it in the terminal. So I'm going to launch again. I'm going to click my launcher, and I'm going to get myself a terminal. Okay. Now, my terminal is going to look a little bit different than your terminal when it starts up. And we're going to learn about that in the next lesson and in the exercises later this afternoon. I have some stuff that's automatically done. I have these key pairs that are set up so that I can play with Amazon Web Services. You will not see this part here. Your prompt is also going to look different. Mine has this because I made it fancy. And again, you're going to learn how to make it fancy later today. But you probably have a prompt that looks something like a % sign, right? Nod, I'm not seeing nods yet. Okay, there's some nods. I see something that looks like a % sign. Okay. So in the terminal, if I want to run it, I can type python zen.py. And so in the terminal, what that does is it says, okay, invoke Python and then run the contents of the file zen.py. I hit enter there, and it does it, and it prints the results to the terminal. Now, there was a question in the Slack channel about what's the difference between terminal and console. Console. So the terminal is giving you access to your machine, all its file systems. It's not running a Python interpreter. It's running a program called that's called a shell. If you're using a Mac that has a more, I think, what is it now? Catalina 10.15. So it's from 10.14, 10.15 on Mac OS. The shell you're going to be running is called Z shell. If you're running Windows, it's called PowerShell. Some of you may be running Bash, which is another type of shell we'll talk about in the next lesson. So that's what a terminal is. The console, on the other hand, this gives you basically the Python interpreter is running behind this, and what you type in the console, it sends to the Python interpreter. So the terminal is running a program called shell, which allows you to communicate with your computer, whereas console is running the Python interpreter, which enables you to communicate with the Python interpreter. Okay. So, right. So there's another really nice, good question. One is that some people aren't seeing a % sign; they're seeing a $sign. That's fine. It doesn't really matter. That's just what your terminal prompt is. And also another question is, where is Jupyter going to save a file when you have a .py file? It's going to save it in whatever your current working directory is. In my case, and you can actually ask. So we're going to learn this in the very next lesson. If I type pwd, which stands for print working directory, it's here for me, which this is the full path to my directory. And it's this is just the folder that I'm choosing to work in. Okay, so let's, the console is nice. Honestly, I almost never use it. What I do is I usually work in a Jupyter notebook, and this is particularly useful for science. So let's actually launch a notebook. So I'm gonna go back to my launcher, and I'm gonna launch my notebook, and this means I'm gonna launch a Python 3 notebook. And so now I'm in the notebook, and you can see it here. It's called untitled.ipynb. I'm going to name it something else because I want it to be more descriptive. So I can right-click and go down to rename file, and I'm going to call it lesson 00. I'll rename it. Okay, and right. So why are we using a Jupyter notebook? The advantage of a Jupyter notebook is that you can mix code cells with cells that have explanation. So what do I mean by a cell? So right here, this thing where I have right here, this is called a cell. It looks like a prompt from the console, and it's got this little prompt in front of it, which means that it's a code cell. And you can tell that it's a code cell because right here, this little drop-down menu here tells you what kind of shell it is. And the choices are code, markdown, or raw. We're not going to use raw. I almost never use raw. There's very rare instances where you will use that. And a code cell is just like it would be something that you would type into the console that we saw before. So if we want to do hello world in a Jupyter notebook, we would do print hello world, just like we did in the console, and again hit Shift Enter to make it execute. And then the nice thing is with the organization of the notebook is that it executes and gives you the output right under the cell, and then gives you another, and then you get another cell after. Now, if I wanted to add text to a cell to describe what I'm doing, then I choose a markdown cell. Now, markdown is a markup language. Just, have you guys heard of any markup languages? Anybody know any markup languages?
HTML.
Yes, HTML. That stands for Hypertext Markup Language. Basically what that is, so in HTML, you format things so that it looks a certain way in the web browser. It's not just plain text. You can make things bold, you can underline things, you can make things links and so on. Markdown is a markup language, meaning that you can make things you can, have your text not just be plain text, be bold, italics, that kind of stuff. But it's like sort of a simple one. Doesn't have a lot of functionality, but I think that's a good thing. It lets you do the easy things easily. So notice that when I'm in a cell and I choose markdown instead of code, notice that the prompt is gone, and now I can type text. When I hit Shift Enter, what it does is it renders the text. Now I can also do things like I can put headings. This is a heading. Now it gives me a nice bold heading, and it tells me, and then I can have text after it. I can also type bold text, right? And it makes it bold. The way to make it bold is you put double asterisks on either side. I can even type italicized, with one asterisk, and it will be italicized. And then here we go, hold on for the cool part. Yes, I can even do math. So those of you who are familiar with LaTeX, it will interpret LaTeX. Sometimes you have to run it twice, and it will give you nice equations. We're not going to cover LaTeX or anything like that, but you can actually get really nice equations. Okay, the final thing I'll mention is that in Jupyter notebooks, you can basically use them as calculators. Whatever the last thing you enter in a cell is will be displayed. So if I did 7 plus 8, that should give me today's date, 15. But if I do some other calculation, 9 minus 6, it only will display the last one. So it's going to display whatever your last calculation was. Okay? So that's a flavor of the tools we're going to be using. We're going to use the terminal and the Jupyter notebook. So what we're going to do now is we're going to take a 5-minute break, and at 1:45 we will come back.